This is about the microservice architecture, which I explained. Right now, guys, we will try to see microservice architecture. How can we create the microservice architecture? Okay, let me show you with a diagram again. Okay, so again, there will be 3 developers. So this guy is working in order. He is working in, suppose, payment. He is working in inventory. So he will have its own GitHub repository. He will have its own GitHub repository here. GitHub repository. You can create one GitHub repository, different folders also if you wish. Okay. But suppose different GitHub repositories there. He is writing something in PHP. He is writing in Python. He is writing in Java. Okay. Now, this will have its own cycle where you will build it. Build will be by just use the zip command to build, because this is PHP. It's an interpreter language. You don't have to compile it. So just zip it to create a zip file. Similarly, for Python, you can zip, because again, it's an interpreter language. For Java, you need to use what? Maven. You will have to compile, right? So build part will be compile and then package. Okay. So WAR file will be created. So you can use Maven. Okay. So this is your build part. This is your SCM, source code management. Right. Now, once you have that zip file, the artifactory, we call it as an artifactory. The artifactory will be created like maybe order.zip. Right. This will give you what? This will give you as payment.zip. Right. These are artifactory. And this will give you what?
WAR package.
WAR file. Right. So WAR file will be inventory.war. Fine. So you will get these 3 artifactory. Right. This is called artifactory or artifact. Okay. We can call artifact the final end result. Artifact. Okay. Now, once you get these things, what will be in microservice architecture? What mechanism you should follow? Once you get this artifact, your tasks should be, now you will do the, once the artifact is created, okay, you need to do the Docker build image. Okay, you have to create an image out of it. So just like in AWS, we created AMI. Remember, similarly here you need to create what? You need to create a image. Okay, this image will be, think like you need to create a image. Okay, Docker image you will create. How will you create Docker image? With the help of a Docker file. So you will use Docker file plus this artifactory. Okay, plus. Okay, everything will have different Docker file. For now, Docker file, you just understand that there is something called Docker file. We will see how to create Docker file. With this, you will create Docker images. Okay. So this Docker image is a order image, order Docker image. This will be payment image. This will be inventory image. Okay, image. Image means just like that snapshot, AMI kind of thing. But very small size, not like AMI, 1 GB. It's very small size, 100 MB. Once you create this image, with this you will create a runtime, which is nothing but a container. The instance of image is container. Right? You will create a container. So this will be container. You will be creating container. Right? This containers. You will be creating. Now these containers are, this is order container. This is payment container. This is inventory container. So this is one microservice, this is one microservice, this is one microservice. Why we are saying microservice? This is running, this container is nothing like a server. It is acting like a server. All these three containers are in one single server only. Remember this. All the three containers are in single server. For now. Okay. And all these three containers have different IP. 172.17.0.1. Okay. All these containers have different IP. Okay, and this server is also having one IP. Suppose this is a public server with private IP. As I told you, server will have public, but then again it will also have private IP. So this server is nothing but this server, this virtual machine, inside which you will run three containers, which will have three small containers, which have three IPs, private IP only. And then this all will be talking to each other. Because these are in same network, you see, same network. So there will be a Docker network created. Then this will talk to each other. So if suppose somebody is coming and asking for order, so it will come to order. And then if order needs payment module to work, order can talk to payment module. Even payment wants, suppose inventory to check, payment can talk to inventory also, because these are all in same modules. Every module will are running in different tech stack. So this is nothing but called tech stack. Like what is the tech stack? PHP is my tech stack. Python is my tech stack. Java is my tech stack. Okay. So that is the thing. So this tech stack you will be using, and along with that you will create containers that will have different IP, and this will be done. Clear? This kind of thing you need to use. So you need to somehow create a Docker file. Along with this artifact, you will create an image. Once image is created, you need to create a container. Once the image is done, half of the task is done. Container creation is like a baby task. You can create a container. So here you are running the containers in one single server. But in real life, suppose you are working for Netflix, you are watching movie, another guy is watching movie. Everyone, whoever is watching movie, they will have, once you start the Netflix, they will create a small container for you. And you will be watching, that means for you, there will be specialized container, specialized server. And from that server only, you are watching everything. Once your TV off, once you move the TV off, once you keep the TV off, Netflix session is off, gone. Your session, your Docker container will be killed. Okay. So these containers are created where your services are running and customers will be able to access. All three are interconnected. So in that way, we can save lot of, we can actually segregate that, okay, that this is working in PHP, okay, better. I will develop in PHP only. Again, I can limit the order. Suppose if this developer is doing something wrong, he is having some same case which we discussed last video, that okay, if this particular inventory module developer is doing something wrong, some buggy code, that will not impact payment, that will not impact order. Inventory will be separate altogether, right? Because this is a separate, only you have to fix this. You can have a separate page here, That if suppose somebody is going from payment to inventory, a customer may get that okay, inventory module is not working now, it may come up very soon. They will get that intimation. Okay, so you can manage this many things in this way. So I hope you all understood what is the reason behind we use microservices. Okay, with this little diagram. Okay, so now we will do practical. Okay, so I'll be sharing you some document. This is the document which we'll be sharing. Okay, here we are explaining the same thing. An online shopping where account service, product service, cart server, order server, different module, different account database. See, different databases is there. So this order can have its own database, payment can have its own database, inventory can have its own database, right? So that if the database is having individual databases are there, so then the data will be separated. Your database size will not be more. If you keep all the data in one single database, it will be a huge database. Okay, performance issue will come. That means a database size is more, lot of data is there. That means if you run a query to get the data, it will have to fetch or query from lot of data, some small set of data, right? So you need to tune more. Performance tuning should be more. Okay, but then here in this case, if the database is small, your complexity will be reduced. Okay, because one single microservice pointing to another microservice.